Today, almost all oscilloscopes generate automated measurements by performing math on waveform data. Not all oscilloscopes use the same technique, however, which affects the precision and accuracy of the measurements. Let's look at a comparison of the same waveform measurements performed on both the Tektronix MDO4000C and the Keysight X4000A. Both the Tektronix MDO4000C and the Keysight X4000A acquire more data than the horizontal display resolution. Therefore, the acquired acquisition data is converted to display data before the waveform is shown on the oscilloscope display. But there is a difference in the way each scope handles measurements. The Tektronix MDO4000C waveform measurements are performed on the acquisition data, while the Keysight X4000A waveform measurements are performed on the display data. Let's see how this will affect our measurements when using different zoom settings as we measure the rise time of a specific pulse. As we zoom in on the waveform, the rise time measurement stays consistent at 13.25 nanoseconds. Even as we pass through 1,000 times zoom and ultimately to 10,000 times zoom, the rise time measurement stays consistent at 13.25 nanoseconds. We see that the measurements of the Tektronix MDO4000C remain the same with different zoom settings. This is because the acquisition waveform data is being used for the measurement, not the display data. This isn't the case on the Keysight X4000A. The measurement starts at a result of less than 96 nanoseconds. And as we start to zoom in on the signal, the rise time measurement changes. It goes to low signal, then to 14 nanoseconds, changes to 11 nanoseconds, and back to 13 nanoseconds, and finally to 13.8 nanoseconds. Here the rise time measurement changes with different zoom settings because the display data is being used for the measurements. How do you know which rise time measurement to use when different zoom settings change the rise time measurement? Keysight Technology's user guide warns about using zoom. It says, because measurements and math functions are performed on displayed data, you affect the resolution of functions and measurements. Even with this knowledge, this is a major limitation to making consistent, accurate measurements. When you're selecting an oscilloscope, make sure you pick one with consistent and reliable measurements that don't change with different zoom settings.